Hi guys, it's me again, Rachel. Welcome to another video tutorial. So the lesson that I am going to share to you today is all about Pythagorean identity. So this tutorial is intended for those students who are struggling in understanding and deriving the Pythagorean identity. So without any further ado, let's get into the lesson.
As I have said earlier, today's topic is all about Pythagorean identity. Pythagorean identity is very important in trigonometry as it is very useful in verifying identities and solving real-world problems. These are the Pythagorean identities. These three are the main Pythagorean identities, and the six red ones are the new Pythagorean identities that we can derive from these three main Pythagorean identities using the addition property of equality. So this, we can derive these two new Pythagorean identities through this first identity, and this two is for the second and another for the third identity. So I'm just going to explain this first two, how did we came up using the addition property of equality, and you're going to do the rest as they have the same process. So as I've said, we're just going to use the addition property of equality. Just add a negative cos squared x to the both sides by this expression. How we can have a new trigonometry identity. The sine squared theta is equal to 1 minus cos squared theta, and here we can just add a negative sine squared theta to the both side and do the math. We can have a new trigonometric identity. The cos squared theta is equal to the 1 minus sine squared theta, and do the same way as I did in this two box. Just use these two remaining identity, and we can have new trigonometric identities. The tan squared theta is equal to the second squared theta minus 1, and 1 is equal to the second squared theta minus tan squared theta, and 1 is equal to the second squared theta minus cotangent theta squared theta, and cotangent squared theta is equal to the second squared theta minus 1. And we can have a new trigonometric theta from this main identity, which is this 6 is very useful in verifying identities. As you can encounter this term, you can just simply put its equivalent to verify the certain identity that's being asked to you. Now we'll just focus on this three Pythagorean identity first. So we're going to prove how did we come up or how did we derive that three Pythagorean identities. So Pythagorean identities can be derived from the Pythagorean theorem. This is the right angled triangle. The longest side is our hypotenuse. The C and AB are the legs. And the Pythagorean theorem formula is a squared plus b squared is equal to c squared. Now first let us verify, or prove the derivation of basic Pythagorean identity. Sine squared theta plus the cos squared theta is equal to 1. Try to focus on this figure. This is a right angled triangle in a unit circle, and this is our angle theta, or theta angle, that is equivalent to cos x and sine x. Since the A is the x and B is the y, and Pythagorean identity, the hypotenuse is always equal to 1, and that's the rule. The rule. As in the right angle, use the Pythagorean theorem, the a squared and b squared and the c squared. Since a is the adjacent, it's the 6, b is the opposite, and it's y, we can just substitute the length to the side. The cosine is the x and the sine is the y. Cos squared theta plus sine squared theta is equal to 1. Now we have our basic Pythagorean identity. Sine squared theta plus cos squared theta is equal to 1. These two remaining Pythagorean identities have the same process. They both use the basic Pythagorean identity. Sine squared theta plus cos squared theta is equal to 1. But the difference is, in this Pythagorean identity, the tan squared theta plus 1 is equal to second squared theta, it divides the basic Pythagorean identity in cos squared theta. In this Pythagorean identity, it divides the term in the basic Pythagorean identity in the sine squared theta. Now let's divide each term of the Pythagorean identity, this basic Pythagorean identity, by cos squared theta. So sine over cos, we know that it is equal to tangent, so we just put tangent here and copy the sign. Plus, we know that cos squared theta over cos squared theta is equal to 1, and it's equal to 1 over cos theta x, and we know that this term is a second squared theta, as cos second squared theta is the reciprocal of the cosine. And now in the term, in this identity, we're just going again what we have did this, we're going to do also in this identity. So we're going to divide each basic Pythagorean identity by the sine squared theta. And we know that sine over sine here, going to divide it by the sine squared theta. And we know that sine over sine is 1. And cos over sine is cotangent. It is the reciprocal of the tangent. Just go and copy the sine is equal to 1 over sine squared. And we know this term is cosecant, since cosecant is the reciprocal of sine. Now we have derive and prove the two remaining Pythagorean identity. The tan squared theta plus 1 is equal to the secant squared theta, and 1 plus cotangent squared theta is equal to the cosecant squared theta. Now, to fully understand the Pythagorean identity, we have an example here, verifying identity. So verify if all Pythagorean identities can be equal to 1. So we have a given triangle here, a right angled triangle, where A, B legs are given and C, or the hypotenuse, is missing. So the first thing that we're going to do is to find the hypotenuse, and we're going to use the Pythagorean theorem. The A squared plus B squared is equal to C squared, and you're just going to substitute the A and B. It's 8 and 6. 8 times 8 is 64. 6 times 6 is 36. And to cancel out the square, we're going to square the both sides. It is the square root of 100. Since 64 plus 36 is 100, that is 10. So our hypotenuse is 10. So these areas, or the sides that we have just get from the Pythagorean theorem, are the sides that measures that we are going to use to verify if all Pythagorean identities can be equal to 1. So the Pythagorean identities that we are going to use are those Pythagorean identities that have equal to 1. First one is the basic Pythagorean identity, this identity. Next one is this identity and this identity. So these three are the identities that we are going to verify if those are equal to 1. To start with, in this identity, the sine squared x plus cos squared x is equal to 1, and we're going to go to the basics, the SOHA. Since sine is so, it is opposite over hypotenuse. Opposite is B, adjacent is A, and C is the hypotenuse. And we're just going to substitute all of that in here. So the sine is SOHA, opposite over hypotenuse, and the cosine is adjacent over hypotenuse. Substitute, do the math, and that is 100 over 100. That is 1 over 1. So this Pythagorean identity is equal to 1. So we verify the identity. It is correct. Now, the next identity is 1 is equal to, so secant squared theta minus tan squared theta. Since secant is 1 over cos, it is the reciprocal of the cosine, and tan is the TOA. We're just going to find here the TOA is the opposite and adjacent, and 1 over cosine, or the 1 over adjacent and hypotenuse, and we just substitute it and do the math. That is 100 minus 36 over 64, and 64 over 64 is 1, and our verification is correct, that this Pythagorean theorem can be equal to 1. Another Pythagorean identity that we are going to verify is this one, that is cosecant squared theta minus cotangent squared theta is equal to 1, and cosecant is the reciprocal of the sine, so it's 1 over sine. Cotangent is reciprocal of 1 tangent, so that is 1 over opposite over hypotenuse, and 1 over opposite over adjacent, and just do the substitution and do the math. That is
100 minus 64 over 36, that is 36 over 36, and that is 1. And that's how we derive that these three Pythagorean identities can be equal to 1 with the given triangle. Now, let's apply the Pythagorean identities in the real world. The Pythagorean identities is fundamental in trigonometry and has a various real-life application in the field of physics and engineering, navigation, signal processing, architecture and construction, astronomy, and others. So the real world, we're going to apply the Pythagorean identity in a real world problem. You have a nephew who loves to skate and starting to learn new tricks. But you have noticed that he practices his tricks in the street, and you thought that he will not learn a new trick if he did not have a new area to practice. That is why you have decided to design a ramp for skating board in a vacant area in your house with an angle of 45 degrees. Find the height of the ramp in meter. Ramp is an area where you're going to do skating and try some tricks. So this will be the first thing that we're going to do is to draw or illustrate the problem. So we're going to draw. So since the ramp is a triangular figure, we can create a triangle figure here. This is the ramp. This is where the skateboard we're going to run. This is the ground, and the angle of degree is 45 degrees, and the height we're going to find the height. When the angle of inclination, this is the angle of inclination, it is an angle between the ramp and the ground. Both the sine and cosine of the angle is equal. Okay. So if the angle of inclination is 45, and we're going to do the harmonics, the equivalent of sine 45 and cos 45 is just equivalent to square root of 2 over 2. Therefore, they are equal. And so, we're going to use the basic Pythagorean theorem. The sine squared theta plus the cos squared theta will be equal to 1. We can determine the height of the ramp. So, first thing we're going to do is to copy the Pythagorean identity that we're going to use and put the theta, or the angle theta is of 45 degrees. So 45 degrees squared cos 45 degrees squared, and sine 45 is just equal to square root of 2 over 2, as well as the cos 45 is equal to square root of 2 over 2, and we have the squared. We're going to square that one. Square root of 2 squared is square root of 4, and square root of 4 is 2, and 2 times 2 is 4. And since they have the same values, we're just going to copy this one to here. I'm going to add that one. It is 4 over 4 is equal to 1 and 1. Therefore, the height of our ramp is 1 meter. Therefore, the height of this one is 1 meter. For you to practice your skills in Pythagorean identities, please try this problem. You are setting up a tent for a camping trip. The tent pole makes an angle of 60 degrees with the ground. Determine the height and the distance from the base of the tent pole to the top of the tent if the tent is 2 meters tall. You can put your answer in the comment section, and God bless for that. And this ends our lesson for today. Let's have a short recap. So, Pythagorean identity, and these are the Pythagorean identities. These are the 3 main Pythagorean identities, and these 6 reds here can be derived through these Pythagorean identities. And we have the derivation of basic Pythagorean identity through this figure, the right angled triangle. We can have the basic Pythagorean identities, and through this, we can get the 2 remaining Pythagorean identities by dividing each term by the cos squared theta and sine squared theta. This ends our tutorial, guys. Thank you for watching my video, and I hope you'll learn something from it and you will apply it to your study. Thank you, and God bless. Bye-bye.